Now we'll try to discuss how we use a receive function that we have in an UART PS, right? So let us just go through an entire code. So I updated a code a bit as compared to our previous case. So here we have our data buffer, okay, which have data which is hello world, okay, and that we plan to send to the serial terminal, right? Now our agenda will be to operate UART in an local loopback mode. So what that will do is whatever data we transmit, we'll be receiving back and then storing it into an RxFIFO, okay, and then we'll be taking out the data from an RxFIFO and then we'll be sending them back to the serial terminal in a normal mode, right? So if you are operating in a local loopback mode and if you try to send the data, you won't be finding anything display on a console because the same data will be stored into the RxFIFO, right? So if you want to see a data onto a console, we need to operate in a normal mode, right? Here, since we have the source data buffer of size 11 byte, so we need to declare a receive buffer data again of size 11 byte, right? So that is what we did over here. We haven't initialized this to any value, okay? Then we have an UART in it, okay? So this perform an initialization of our UART peripheral. Now remember, init platform is also doing the same thing for us, right? And now since we are manually performing an initialization of a peripheral, so init platform is not required, right? So UART init itself will perform an initialization of a peripheral, right? So once this is done, we proceed and first set up the loopback mode, right? So local loopback mode. So here we call UART PS set operation mode. So this is a function that is used to set the operating mode for our UART, and then we have a 4 different modes which are supported by UART PS, right? So we could operate in a normal mode. So here whatever data we send will be displayed on a console, and if you write the data onto a console, that is if you go to a Vitis serial terminal, so here you have an option to send the data, right? So whatever data you feed in here will be stored in a receive FIFO and that we could read. So this is what we refer to as a normal mode. Okay, the other mode that we have is an local loopback mode. So here whatever data we send to a console will be coming back to a receiver and it will be automatically stored in an receive FIFO, right? So we'll be utilizing or we'll be switching between this two mode in this specific example, right? So when we go to the main code, right, here we want to operate in a local loopback mode. So whatever data we write to a console will be automatically coming back to a receive FIFO, and that is what we're gonna read, right? Then we call a send API. Now this allows us to transmit the data to a console, right? We need to specify an instance structure, the source of a data buffer, and then the number of bytes we are transmitting, right? Then we are waiting for the transmission to complete. And once our transmission is complete, we can say that since we are operating our UART PS in a local loopback mode, whatever data we have transmitted will be automatically in an RxFIFO, right? So to take the data out of an RxFIFO, we have a function referred to as a receive FIFO, right? And then receive data. Now this returns the number of bytes that we received or taken out from an RxFIFO, right? So with each new byte we take out from an RxFIFO, we need to increment the count, right? So here we declared one count variable which is of S32 type and we initialize it to a 0. So with each new byte we take from an RxFIFO, okay, this will be returning 1, and that way we will be incrementing the value of a count, right? Now one more thing that we need to make sure is with each new byte, okay, you'll be getting a new element that you want to store in an array, okay? So with each new element you need to update the element out of an array where you want to store the data, right? And how we achieve that is we know that with each byte receive count will be incremented. So when we call received function, here we have an instance structure and then the pointer where we want to store the data, right? So this should also be dynamically updating with each new byte, right? So here now instead of having this as a static, okay, what we are doing is we are calling the receive data, which is the array that we declared for storing the data that we have in an RxFIFO, okay, and the element where we want to store data will be updated dynamically as we change the count, right? So with each new byte we receive, count will be incremented by 1, and this way we will be choosing the new element where we store the value that we received from UART PS, right? This logic that we have written over here will make sure that we take out 11 byte from the RxFIFO Okay, and we store it into the data buffer that we declared for storing the data that we receive from the UART, right? Once this is done, now we want to send the data that we have in a receive data buffer onto a console, right? So we want to see the value of the data that we have in a receive buffer, so we need to operate our UART in a normal mode. Okay, so how we do that is we again call set operation mode. Okay, and here now we are specifying that we want to operate our UART PS in a normal mode, right? So once we set up the UART to operate in a normal mode, okay, we need to just send the data byte by byte onto a console, right? So how we do that is we declared one counter variable which keep the count of the byte that we sent to a console so far, right? So for I equals to 0, I less than 11, I plus plus zil printf. Okay, this is a function that we are utilizing. Okay, and we are sending a byte by byte, okay, to the console. Now here you could clearly see the index is the I value, right? And with each new iteration, I value will be automatically incrementing. So we'll be sending the new data onto a console with each new iteration, right? So this is an entire code. Now first, since we do not know whether it will be working as expected, what we're going to do is, okay, the reason why we do not know whether it will be working as expected is because we are utilizing both the method, right? So here you are utilizing the lower level API to send the data to a console, whereas here you are utilizing an higher level API, right? So zil printf, okay, to send the data. So in that case, we need to trim our application such that it operates properly, right? So first, let us just build our application project and try to observe whether we are getting an expected result. So if we do not get an expected result, we need to work around just to modify this an application project so that we get an expected result, right? So once our build is finished, we select our application project, right click, debug as, launch on hardware, right? So this will automatically start programming our FPGA. So once programming is successful, okay, we'll be going to a YT serial terminal and then connecting it to the respective COM port, right? So in my case, it is COM4 and we are operating at 9600 baud, right? So click OK and then click on resume button, right? Now here, the first thing that we are expecting is UART init successful, right? But here you could clearly see we are just getting UART init and then S, right? So if you count the number of bytes that we have received, so 4, 4, 8, 9, 10 and 11 byte we have received, right? So this is okay. So you could see here we are receiving 11 byte and 11 is something that we specified over here, right? So our application is not working as expected, right? So what we can do over here is, okay, as we set the baud rate, now let us forcefully specify an operation because this we want to see on a console, right? So here the mode of operation should be normal. So let it just go ahead and call this over here, right? So this will make sure that we work in a correct mode, that is a normal mode. Now here we are sending the data. Now we'll make sure that we do not execute the next statement until we send all the data, right? How we can make sure that all the data is correctly transmitted to a console or not? We could just call this function, right? So we will be waiting till all the data is transmitted, and then as we complete the transmission, this will return 0 and then will be coming out, right? So this will be the first modification that we are doing. So we are forcefully setting up the correct mode that we want, and we are waiting till all the data that we intend to send to a console is sent onto a console, right? So once this is done, now we proceed and then we'll again build up our application project, right? So let us see whether now it works as expected, right? So once our build is finished, we'll just be selecting our debug session and click on relaunch. So let's just clear our console, right? And then we will be clicking on resume button, right? Now you could see UART init successful and the data that we have in our received data buffer is hello world, right? So this is how you will be trimming your application whenever you are working on different levels.